is the last part of what is going to make up your third and final test for this class. So 5, 6, and 7 is what that test is going to be over. Chapter 7 is all about hypothesis testing, which is a pretty big idea in statistics. 7.1 introduces it. 7.2 talks about if we know the mean and population standard deviation to get the mean. And then 7.3 is if we don't know the population standard deviation to get the mean. We're also going to do 7.4 a little bit with proportions like we did in chapter 6. Each of these sections has quite a bit of material it covers. So if you look at our calendar, it's going to break it down into small bits. So for example, 7.1 is 3 days of lessons. And if you look at your Math Excel, there are 3 Math Excels. Each Math Excel goes with each day's lesson. So like today, you can complete 7.1 day 1 Math Excel, and it's just going to cover what we do today in class. 7.1 day 2 covers day 2, so on and so forth. All 3 7.1 Math Excels are due on the same day, which I think is next Tuesday, next week. But the goal is we're going to just do a little bit in class each day. You guys don't have full Math Excel work days built in, but the lessons are smaller. We're like chunking it. So this will only be like maybe 15 minutes today. And then the rest of the period is yours to work on, hopefully specifically that Math Excel, get it done, and then we do the next part the next day, and we just kind of build from there until we get to the end of the chapter. Does that make sense? Okay, cool. All right. So today, just introduction to hypothesis testing. What we're going to practice today is creating a hypothesis and an alternative hypothesis. We'll call a null and an alternative. So a hypothesis test is a process that uses sample statistics to test a certain claim about a population parameter. The first good set of stuff that we do is going to be testing the mean, but eventually we're going to get to proportions as well. You could also use this to test like standard deviations or variance. We don't get too much into that kind of stuff in this class though. And then a statement about a population parameter is called a statistical hypothesis. So what is a statistical hypothesis? It's actually made up of 2 different things. So when we write a hypothesis, we have what's called a null hypothesis and an alternative hypothesis. The alternative hypothesis is the complement of the null. So they are complements of each other. The null hypothesis contains a statement of equality. That's going to be really important because sometimes you're going to be asked to name which one's which. The one that contains less than or equal to, greater than or equal to, or equal to is the null. The one that does not contain the statement of equality, so just greater than, less than, or not equal to, is the alternative hypothesis. Either one of these could be the claim that's being made. So we could claim something about equality, or we could claim that something is strictly greater than, less than, or not equal to, and then you'll kind of see the math behind it later. But for right now, just kind of creating these statements are what we're trying to do. Okay, so kind of seeing on a number line what sets these make up. And again, you can be testing lots of different things. The ones that are listed here, that lowercase p, remember, is a proportion that we're making a claim about, and then we've got the other 2 at the bottom, which are means that we're making a claim about. Okay, so in the original one, we have h sub 0, that's the null at the top here. And the null is that a proportion of something is equal to 0.61. So 61% of people said this, whatever that means, okay? And that's the claim. Then at the bottom, where you see the subnotation with the a, that is the alternative. So the alternative is the complement. It's if one's equal to, the other one's not equal to. Now what that looks like on a number line, h sub 0 would be a single point at 0.61, okay? And h sub a, my alternative, would be everything else above it and below it. Everything except that specific value, okay? The one in the middle is when my null is less than or equal to, and this is about 18 years being a mean of something, okay? So if I wanted to graph that, close circle at 18, and then everything below that would be my null hypothesis, and then everything above it would be my alternative hypothesis. Okay, so notice that in both cases so far, we're covering the whole number line. Total is equal to 1 if we're talking about probabilities or areas. All right, and then the bottom one, my null hypothesis, the mean is greater than or equal to 15 minutes. So again, wherever 15 is, and everything larger than that would be my null. And then everything smaller than that would be my alternative. Those bottom two, notice the claim that's being made is actually the alternative hypothesis. So we're claiming that the mean is greater than 18, or we're claiming that the mean is less than 15. Okay. We'll talk about later with these two how the claim isn't necessarily we're trying to prove something we're trying to prove. Sometimes it's going to be something we're trying to disprove. So that could make a difference on whether we make the claim the alternative or the null. All right, flip it over. Okay, so we have some mathematical statements here, and they represent a claim. We want to write its complement and then state which one is the null and which one is the alternative. Okay, so this first one, what is that symbol, that little sigma squared? What's that the symbol for? Do you remember? It's variance. So this is a statement about variance. The claim is that the variance of something is greater than or equal to 1.2. Okay. If it has a statement of equality, it's got the equal symbol, is it the null or the alternative? It's the null. Okay. The alternative then, we need to write is the complement of that. So the complement of something being greater than or equal to 1.2 is that my variance would be what? What's everything else? Less than 1.2. Absolutely. And that's it. That's all you have to do. Okay. So the one in the middle, we have a statement, a claim being made about what? If it's just the lowercase sigma, not squared. What's that notation for? Standard deviation. So the claim is something's standard deviation is not equal to 5. If it's not equal to, is that a null or an alternative? What do you think? Alternative, agree. Which means my null will contain the statement of equality. So my, oops, why aren't we writing? There we go. Standard deviation is equal to 5. It's the opposite, the complement of that. Okay. Last one is a statement being made about a proportion. The proportion of something is less than 0.45. So it's less than 45%. Are you guys all done? Yeah. Oh, great. If you just want to put the extra supplies on that first table there. Do you need passes to go anywhere? No, you're good. Okay. Perfect. Thank you for your help. All right. So is this claim null or alternative? What do you think? What, Mia? Alternative, which means I need to write the null hypothesis, which is that a proportion instead of being less than 0.45 would be greater than or equal to 0.45. Okay. Questions on any of those? Reading one from the other. Okay. So now, on this slide, I think you guys have some of this revealed on yours already. Let me get my little, where's my little select tool? There it is. Okay, so you guys have this stuff on there already on your paper? Yes? Okay. So most of the time, we're not going to be given the mathematical statement. We're going to be given the statement in words as a claim, and then we're going to have to interpret those words into the mathematical statements. So these are all the different ways that you could see on the left a null hypothesis written, so statements that contain equals, equality, and then on the right side an alternative hypothesis written. In the middle are, if you see those phrases, what the null and the alternative in mathematical statements would look like. So that's what you need to fill in. So these are the three cases we just talked about, but then you can attach the phrases that go along with them. And this is what we're really going to be looking for in our problems. Okay, good. All right, so let's practice. It says, write each claim as a mathematical statement, state the null and alternative hypotheses, and identify which of the two represents the claim. Okay, so we're looking for those key phrases. A consumer analyst reports that the mean life of a certain type of automobile battery is not 74 months. Okay, so a couple things you want to look for. What the claim is being made about. So mean, variance, standard deviation, proportion, probability, something like that. Okay, so it's being made about the mean. And then the phrase that I see is not is what I want to focus in on. Okay, so I'm going to start with the claim. The claim that's being made is that, and it's always about a population, so we always want to use our population symbols. The mean population is not equal to 74. What is the complement of not equal to? Equal to. So that's going to be my other hypothesis. And then we just need to label which one's the alternative and which one's the null. The one that is equal to is my null. The one that is not equal to is the alternative. So in this case, the claim is the alternative hypothesis. Okay. Let's look at the next one. An electronics manufacturer publishes that the variance of the life of its home theater systems is less than or equal to 2.7. Okay, so the claim is being made about what? What population parameter? Variance. And the key phrase, less than or equal to. All right, so the claim, variance, which is my little sigma squared, is less than or equal to 2.7. What's the complement of something being less than or equal to? Greater than 2.7. Equal to is the null. Not equal to is the alternative. Any questions so far? Okay, all right, last one. A realtor publicizes that the proportion of homeowners who feel that their house is too small for their family is more than 24%. Okay, so this time we're making a claim about a proportion. And is more than is the phrase we want to focus in on. All right, so writing my claim. The claim is that a proportion, population proportion, we use a P, is more than, greater than, and then proportions we use decimals. We know that, 0.24. It's strictly greater than, so it's an alternative hypothesis. Use my other color there. Then if I want to write the null hypothesis, what's the complement of something being greater than? Less than or equal to. Okay, good. All right, so The last 4 are yours to try, and we're going to put answers up on the board. So you will probably be either in charge of writing the null, the alternative, or labeling which one is the claim for one of these 4 problems. So I'll give you a few minutes. As soon as we get all the right answers up on the board, we are done for today. That's the end of our lesson. Let's put a little more in there. And this is the last one, and this is super tricky. The claim being made is actually this. So they are claiming that the percentage of whatever is 73%. If the claim was this, they would be saying the percentage of students is not 73%. So don't get hung up on what the 73% represents. Does that make sense? They're claiming that it is 73%. You with me? Okay, it's kind of weird to word it that way, but that's what the claim being made is. Okay. Other than that, looks good. Any questions on creating, interpreting, null, and alternative hypotheses? All right, so you guys have 25 minutes now. You can absolutely get the 7-1 Part 1 Math Excel done in class. They're pretty short little Math Excels. And then tomorrow we'll continue this. We'll add another layer to it. Okay? Cell phone water. Winner is 11. Oh, somebody won. Who's in 11? All right. I think I have quizzes to get back to you guys too. Get those out. I think you hand out for tomorrow yet? No, or not. Thank you. Thank you. No, you're welcome. Yes, I'll send you down. And then open notes. You may use your graphing calculator for this. Let me figure it out here. There you go.